Hello. In this video, we're going to talk about the point-slope form of an equation. Now, we're going to start with the slope formula. If you remember, m means the slope, and we subtract our two y's and divide by the subtraction of our x's. It's a change in our rise over the change in our run. So what the directions here suggest is that we're going to take both sides of this and multiply by the denominator. So let me rewrite this real quick here so I have some space. And then we'll take both sides times the denominator. Now, when that happens, remember how this works. So we have that thing over 1. That's how a fraction works. Any number can be written as that number over 1. And when we multiply fractions, we multiply across the top and across the bottom. But because multiplication and division can happen in any order in the order of operations, we can do our division first, which is this x2 minus x1 here, dividing out that x2 minus x1 there. Okay, we have something dividing and something multiplying, and they cancel themselves out. So that whole side just becomes y2 minus y1. The other side, our slope, m, is being multiplied by x2 minus x1. Now let's consider for a moment that our line has a point on it of x1 comma y1 and a slope of m. There are many, many, many other points on that line. And so we'll call those points, because they have to change, we'll just refer to them as x and y. So what we're going to call the point slope form of an equation, my y2 and x2 are just going to become our generic variables, the x and y combinations that are consistently going to change because there are so many of them. There's not one specific thing that we're going to plug in. So we have y minus our y value point y1 equals the slope m times x minus our point x1. And so noting that we have our point x1 and y1, we have to plug in there and there for those two, and we have our slope of m, and there's m right there. So those are what we plug in for, and we leave x and y all by itself. Let's do some examples where we actually use the point-slope form. In these problems, I have some information about a line, and we're going to write each one in slope-intercept form. So to start with, we know we have a slope of 4 in number 1, and we contain the point -1 comma 2. So this will be the point x1 comma y1. So my x1 is going to be -1, and my y1 is going to be 2. So to fill in, using the point-slope form, so there's the rewrite of the point-slope form, let's fill in what we know. And so we know that we have y minus, and we said y1 was 2, equals, m is 4, and then x minus, and we said our x1 was -1. So when we can just make this look a little bit nicer because two negatives make a positive. So y minus 2 is equal to 4 times x plus 1. And that's our equation in point-slope form. Let's look at number 2. In number 2, we don't have the slope. So we need to start by finding that. So m, we find, remember we subtract our y's, so 1 minus -5. And then we subtract our x's, 1 minus 3. Well, 1 minus -5 means 1 plus 5, which gives us 6. 1 minus 3 is -2. And so this simplifies into the number -3, and that's my slope. Now, which one's x1 and which one's y1? It doesn't matter which one you pick as long as whatever you choose for x1, its partner has to be y1. The nicest of the numbers is probably these, so we'll say x1 is 1, and y1 is also 1. So when we write our point-slope form, y minus y1 equals m times x minus x1. Y minus y1 is 1. The slope is negative 3. X minus, and then x1 is also 1. And that, nothing really to clean up there, that is the point-slope form for that line. Okay, so that's your crash course on point-slope. For now, we are done.